In this work, a deep learning approach for biomolecular event extraction in scientific documents, the main motivation is that the biomolecular scientific documentation is growing very fast. However, the information extraction techniques are still very slow and inaccurate, as well as that the knowledge extracted from these text resources is very superficial. So the knowledge that could be inferred may not be being exploited. So based on this, we are proposing to develop an event extraction model, which is part of the information extraction techniques in natural language processing, and is basically the prediction of the relationships between some entities and the processes where these entities are being part of. So for example, here there is this entity BMI1 classified as gene or gene product, and this other tumorigenesis, which is classified as carcinogenesis. And on the other hand, these processes overexpression as promote, classified as different type of processes. And in event extraction, a process is called as a trigger, and it's basically saying that there exists an event. So the relationship between this trigger and this other entity is what we can know as an event. So for example, here we have now another trigger, but now instead of being related to another entity, it is related to another event. So this is what we call as a nested event. So to develop this type of technique, we need to develop a deep learning model, and we have some golden data as input data, which is going to be submitted in this case to a bidirectional non-short-term memory layer connected to a convolutional layer. And what the model is doing can be divided in three main stages. Firstly, identifying the entities, then identifying the triggers, and finally identifying the events. So in summary, we can see that event extraction is a complex technique because it is including different event types as well as different arguments and different roles. And some of the limitations that are still in the literature are that the sources are presenting very long sentences, which becomes difficult to find the relationship between the words, as well as the domain or vocabulary can be very specific. So probably there is not golden data that can be used for the training or the evaluation of the model. The events can be nested or overlapped, as we saw here, and this is more difficult than finding a simple event. And finally, the event extraction requires high computational cost, but is still presenting low accuracy and results.